Welcome everybody to day 2 of CSCI 41. The first day was a syllabus review. Today is the first real day. And today we are going to review the entirety of CSCI 40. But we're not going to teach it from the perspective of somebody learning it for the first time. Instead, we're going to review basically all of the basics of C++, and maybe teach you a little bit of new stuff about what's going on, so you're not going to be completely bored out of your mind. So let's begin. So yeah, we got a lot of cool stuff here today, but let's just start with the 6 pillars of computer science. Okay, so today we're going to be talking about variables. We're going to be talking about algebra, if statements, loops, functions, and I/O. You can throw classes on there, but we're going to have a series of lectures on classes next week, so we're going to put that off for now. But this is basically the kind of stuff you should have learned in CSCI 40, and if you didn't, you're going to learn it now. Vectors 2. Okay, so the first thing we usually start off with in a C++ program is an include statement. Modules are coming. We're going to be able to import things. They're still not ready yet, so in the meantime, we do an include. Now, a lot of people just kind of type this, we'll just include IOStream or something like that, but they don't really know what it does. So what a hashtag include does is it actually copies and pastes the entire file where that line of code is. And so if I were to include a.text, which is a file I have in my current directory, I hope, maybe, I don't know. See if I do, vim a.text. Yeah, there we go. Look at that. Does that look familiar? It's like the beginning of Hello World, right? Hashtag include IOStream, using namespace standard and main with an open curly boy and no closed curly boy. So you want to see something horrendous, watch this. Now, you can see the IntelliSense is not liking this very much, but it compiles, and it is a fully functional Hello World implementation. Because the first 3 lines of our standard, hashtag include IOStream, using names, all that stuff is in that file, and so it's literally just copying and pasting that file here. And I don't like it. I don't think you guys like it, but it works, right? Tomfoolery, chicanery, yes. Here, let me indent it. There you go. It's much better now. It's properly indented. So if you've ever been curious about what your file actually looks like after you do a include statement, the -E compile flag will actually show you. And so this is what my file actually looks like after all of the includes are done. And you can see there's a lot of stuff in here that doesn't look like anything I wrote. The reason for that is that my include also included IOStream, and IOStream includes all this stuff. And so you have what's called transitive including. A includes B, B includes C, C includes D, so A includes D. And so you can see all of these different header files here have been included. All told, my file is quite long. If I go to the very end, though, you will see here the using namespace standard, the main, and the hello world. It's been annotated slightly, letting you know which file all this stuff came from. This came from a.text. This one came from main.cc, so that the debugger knows which file to complain about if something goes wrong. So this is actually what the compiler sees. The compiler doesn't see your source code. The preprocessor, the thing that handles the hashtag stuff, you can consider it part of the compiler, but it's really a separate step that runs before it. It's a separate executable that runs before the compiler runs. It depends on your terminology, I guess. G++ kind of does all of these steps kind of under the hood, so, it might just be a philosophical distinction, but to me, the preprocessor actually is a separate program that runs before the compiler. And so your compiler doesn't see your source code, your compiler sees this, okay? And it's something called a translation unit if you care about terminology. And there is our hello world, just garbage, right? Just garbage. So let's take that out, and let's include something a little bit different, which is read.h. And so the read.h, using namespace did like that, The read library is a library that I wrote, and the benefit of it is to make I/O, which I have as number 6 here, but we're going to talk about it right now. It makes reading, hence the name read library, it makes reading easier and more clean. Okay, so the GOAT library, thank you. So if we wanted to read an integer, we would have to do it like this, right? Some people actually do it like this. Like, please enter a number. Okay. And I don't like this for a couple of reasons. First of all, x is uninitialized. Through long years of experience programming, I can tell you, you never want to have an uninitialized variable in your code. Well, what if, we're going to read it in right here. What could possibly go wrong? And with this, maybe nothing. But last semester, I had a student who for 10 hours was trying to figure out why his code was randomly crashing. And what it was he had a uninitialized variable. And he was very confident that no matter which path of if statements and else if statements and things like that, it would pick up a value one way or the other. And I'm like, yeah, but what if that's the value? And he's like, oh, yeah, then it's uninitialized. And then some of the time it's 0 and some of the time it's not. And his code would randomly crash. And he spent 10 hours doing that because he did not want to take the extra time and effort to say x equals 0. And if typing 4 characters is too much for you, there is a nifty shortcut, which is open close curly boys like that is only 2 characters instead of 4. So this will set, this sets x is equal to 0. It default initializes the variable. And so you should just always get into the habit of initializing your variables always. Now, so this is an approach you can take, but it's a little annoying because, right, you're initializing a variable and then you're immediately overriding it. So there's sort of this philosophical, like, well, why initialize something if you're not going to use it? So let me show you. This is the standard C++ way. Call this. We'll call this option 1, right? So whenever you write your code, you can do it this way. Let me show you option 2, especially if you did not have me in CSCI 40. Integer x equals read. Please enter a number. Like that. Yep. Oh, we already have an x. We'll do y. Okay. So you can see one line of code does the same thing as those 3 lines of code. You don't have any opportunity for an uninitialized value for y. Y will always have a value. You will never have an uninitialized variable ever when you write your code this way. Also, it just makes more sense for it to be done as a function. You call a function and it returns a value. CN kind of does under the hood, it's kind of like a call by reference way of doing things, and you can't make a variable and initialize it with the value in the same line. It has to be in 2 different lines. So this is just nicer and cleaner. You don't have to use it, but I recommend it. Also, let me show you something else. So if you screw up the input tester, or like you type in a bad value, CN breaks, right? If you type in letters when it's expecting a number, CN goes into the error state, and then to recover from the error state is annoying. You have to, first of all, clear the error flag. You have to copy the bad data out and discard it, and then pull the data out again. And if there's an error again, so you basically have to have a loop that'll sit there and try pulling data out until it does, in fact, get an integer. Watch what happens if you try this with the read library. It just throws it away. And it'll keep asking until you type in a number, and then it works. So it can't ever really go into the error state. The only way it can really kind of permanently go into the error state is if you hit the end of file or something like that, where there's no recovering from end of file. You're at the end of the file. There's nothing I can do about it. But if you get errors and things like that, it will simply discard them and do it again. It makes for a much more robust, much less error-prone input system. Now, some people might want to get to know when there was an error and things like that, and there's options for that. There's, in fact, what's called read optional, and then it will give you an optional int. And what that means is if an error occurred, it returns null, essentially null-opt. But that's maybe a little bit too advanced for you guys. So you don't need to worry about that. That's the basic thing that you need to know for this class. It also works with files. So let's, again, talk I/O a little bit here. Let's talk files, because you're going to need files for your first real homework assignment, which is Friday. Okay, we're going to be doing file I/O on Friday. Due on Friday, like we have a couple warm-up exercises due this week. You've got a GitHub thing. Have you guys all seen this? You guys post on chat. Have you guys seen the little GitHub, welcome to GitHub? It's a little self-guided tour kind of thing. There's nothing hard about it. You just follow the instructions and do a pull request and you're done. 3 points. So just make sure you get that done. Self-explanatory. I'm not even really going to go into it really, because just read the thing and you're done. Do a PR, you're done. You've seen it, you haven't read it yet. You should probably, do that before Friday. It's due at noon on Friday. And then the other homework due on Friday is 99 bottles of beer. Again, that's just a warm-up exercise to get you back in the groove of things. Your first real homework assignment, though, is going to be pushed out on Friday, and it will involve file I/O. So pay attention. Here's how we can do this. So a very common thing that we want to do with file I/O is, like, you might have a file that has like numbers in it and maybe some bad data, and you want to pull all of the numbers out of it and put them into a vector of integers and throw away all of the bad data, like squirrel and apples and nan and things like that. Okay, so how do we do that? You guys all got this? I'm about to delete it. You can rewind the video. It's on YouTube. Okay. So I'm going to make a vector of integers named vec. And in order to do that, I have to hashtag include a vector like that. And there we go. So we got a vector. And we want to open a file. And so we're going to open the file called numbers like that. And so this is how you open a file in C++. You make an input file stream. You have to give it a variable name. By default, I call my vectors vec. I call my input streams ins. Just my integers are called x. My loop iterators are called I. I got nothing better for you. And then this is the file that it's going to open up. It's going to open up a file called numbers. And what we want to do is pull all the numbers out of the file and put them into vec. Okay. And so the first thing you should do when you open up a file is what? What should you check for every single time you guys open a file in C++? Ada, monster. Monster. It's in the fridge. Monster.
Dad, the way Dietame casts is they have to hold some raw fish, and then you have to right click on them, and then they'll tame them.
Nice. Monster. Having a delay is nice. If that file opened, yes, very good. If not ends, then we will print out error opening file. And then we'll just quit with exit failure find, like that. Or you can exit one, either way. Exit is a program, it quits the program. Let's put it that way. Exit will terminate your program from wherever you are. You didn't know that. Okay, so then we will go into a while loop. While true. Talk about loops now a little bit. There are two different kinds of loops. There's while true loops, and there are for loops. And there's more than that, but those are the two that I use. I use a for loop when I know how much I'm going to do. I use a while true loop when I don't. So I don't know how many lines are in numbers right now. And so I'm just going to do a while true loop. If I knew how many times I was going to do something, like with 99 bottles of beer, you actually ask the user, how many verses do you want? And the user's like 3. Then I would use a for loop for that. Okay. So while true, I'm just going to read until I hit the end of the file. Integer x is equal to read from the file, like that. So this is how you can read from a file using the read library. Instead of passing in a string, you pass in a file, and then it reads. It doesn't prompt anything because why would you? You're reading from a file. So it reads the next integer out of the file. If there's an error, it throws it away and pulls out the next integer from the file. It's basically not error prone. The only error you will get out of this is if you hit end of file. So if we say if not ends, we're done. We've hit the end of the file. Break. Break ends an infinite loop. Infinite loop. Okay. So if you do this, you have an infinite loop. You need to have a break inside of there somehow, or unless you're just quitting or something like that. So basically, every while true loop, somewhere within it is going to have an if statement that will stop the loop once we're done. So after we've hit the end of the file, break on the end of file, also known as EOF. So once we hit the end of the file, we're done. Otherwise, we are just going to add it to the vector. So we will use pushback. Pushback adds an integer to the end of a vector. And so this is going to read one integer at a time out of the file and then put it into the end of the vector. And then if we want to print all the elements out of the vector, we can use a range-based for loop. For every integer in the vector, see out that integer. And there you go. There is all of the numbers in the file. So if we look at the numbers file, you can see we got 10, 20, 30, squirrel, 9,000. You can see it only pulled out the integers and it put them all into a vector, and we're good to go. It's that easy, okay? Whereas if you tried doing this using the standard library method of doing it, every time you got something that wasn't an integer, you would have to catch the error, and you'd have to figure out, did we get an error because, we read a squirrel, or because we hit end of file, and like your logic would just look a lot more complicated. So for your homework on Friday, I recommend this as your way of reading data out of a file. It's not too bad, right? Like this little loop here, right here, just three lines of code in a loop. If you wanted to, you can actually make it a one-liner, maybe. Almost. You can almost make it a one-liner. You'd have to pop back at the end, but yeah, like you can actually read all the information out of a file in a very tiny little for loop like that. You're good to go. And I'm actually thinking about adding to the read library to make something even easier, so it could directly read a vector. Give me all the integers out of the file. Give me all the lines out of the file, like in Python. Give me all the strings out of the file. So I've thought about that too. Might be my next thing. Okay, you guys got this? Doesn't doing while ends save you from a particular edge case? Yeah. Normally I would write this as while ends, right? And that prevents this loop from ever running if ends was false to begin with. But guess what we're checking for? Right here. Right. So we're done. Don't need to. You do it that way. Won't hurt anything. Won't hurt anything. It's just in general, ends is going to become false here. Every time you do a read, you should immediately check if ends became false afterwards. Every time you open a file, check to see if ends is false. Every time you read from a file, check to see if it's false. Because at some point you're going to read from a file and there's no data left, and you need to detect that. Okay. All right. So let's rewind back to the basics. Let's talk about variables. Basically, integer x equals 0. This is your basic variable declaration. C++ is statically typed. So in other languages, variables can change types. So you could say like x is equal to hello world. That would be valid Python, right? It would change the type of the variable from integer to string. And C++ is like, no. You have to tell me in advance what type something is. And the reason for that is because in Python, you can get errors that you only detect at runtime, right? Like if you did something like this, like input, give me an int. Does that look like my read library? Yeah. um, the input function in Python returns a string, and a lot of people forget that. And so the type of X changes from integer to string, and then everything like, and you can't tell it compile time because there is no compile time. You just have to run it, and debugging things at runtime gets really time consuming. It's just a lot easier for your compiler to just be like, nope, that's wrong. You made a mistake. X is an integer. You can't do that. You can't make it a string. Done. No. So C++ has something similar to it's still not dynamically typed, but have you guys seen auto before? So auto means deduce the type of X from the right hand side. Okay. So what is the type of X? What do you guys think? Ada, where's my monster? It's too far. Bring it over. Sigh. Caffeine. The type of X is double. It's not float. It's double. Okay. What is the type of auto Y is equal to X? What's the type of Y? Statically typed. You can't change this. Like if you tried changing it to like string, still doesn't allow it. Still statically typed. But it does what's called type deduction. It figures out what type it's supposed to be. So Y is also double. It would be char if we had a single quote here. If we had a single quote there, Y would in fact be a char, or a char, as some people say. Is it the char bearers or the care bearers, right? So, yeah, Y is a double, just like its daddy. Okay. What's the type of X and Y now? What do you guys think? Yes. Very good, very good, very good. It is in fact a flute. A flute. A float. Good. What about now? What is the type of X and Y now? Everybody should know this one. Please tell me you know what the answer is to this one. This is easy. Good. Yes, you are correct. It is int. All right. What about that? What's the type of X now? That's an L, not a 1. 3L. Long? Sure. What about 3LL? What's the type now? LL Cool J. It is in fact a long. Yeah, very good, very good. What about that? What does a U mean? What do you think? Unsigned integer. Good. Now, here's an interesting question. What if we had, because in the previous class, I had a very good question asked. If we have a value that can't be negative, right? Like, if you have row, you have column, and these are like screen coordinates, like which row, which column you are on the screen, right? Can you have a negative row? Can you have a negative column? What do you guys think? No, you can't. So the student was like, why don't we make it an unsigned integer if it can't be negative, right? Okay. Actually, let's see what I do here. Okay. So the student was like, why don't we make these unsigned? Because they can't be negative, right? And my advice is actually not ever, how do I use that screen? My advice is actually to not ever make variables unsigned in general. Unsigned integers are only there for an optimization, for a very specific optimization. That optimization is so that you do not need to check if the value is less than 0. So if you want to see if a number is between 0 and 10, normally you need 2 if statements or like an or or an and or something like that, where you check to see if it's less than 0 or check to see if it's greater than 10, right? If you have an unsigned integer, you can throw away one of those checks. It's an optimization. It is not something you should do by default. By default, you should make your code readable and maintainable and bug-free as possible. Unsigned creates bugs and really, really hard to find bugs. You're like, how is that possible, right? Let me show you. So let's say that you've got 1 point on the screen. Like here, it's like row, what is that, like row 5, column 10. And then you got another point on the screen over here. Row 10, column 20. And you want to see how far apart, you clicked, and you want to know how far apart are the 2 points on the screen that you clicked. Okay? You guys understand? It's a very common thing. Like you drag the mouse, and you have to know how far did the person drag the mouse because you're moving a unit or you're moving an icon or something like that, right? You guys with me? How do we tell? How do we tell how far apart 2 points on the screen are? We got a row and a column, and a row and a column, and we want to know how far apart they are. How do we do this? Using mathematics that we learned in 7th grade or 8th grade. What's the name of the formula, the function? The distance formula. Yeah, what's it called? It's named after a guy who founded a religion. You guys know this? Pythagoras? Do you know he started a religion? They would walk around with triangles on their heads and things like that. Yes, the Pythagorean theorem, right? So maybe we'll do a little function right now too. Switch over to functions. So your basic function takes an input, returns a value as output. And so for something like this, let's say unsigned int pythag, and it's going to take in unsigned int row 1, unsigned int column 1. Cheat that a little bit. So it's going to take in row, column 1, x1, y1, x2, y2. Okay. And so we are going to return the square root. Do you guys remember this? The Pythagorean theorem? Right. Okay. Square root of row 2 minus row 1 squared plus power of column 2 minus column 1 squared. Have my and for pow and square root, we need cmath. And there we go. So the distance formula in algebra is just that, right? So you have a point and a point. You difference the x's and square them. Add that to the difference of the y's that are squared also. Square root the result. You guys remember this from back in the day? Yeah. Cool. Does that look about right to you guys? pow of row 2 minus row 1 squared plus the pow of column 2 minus column 1 squared. But good. Pretty solid. So, cout pi tag row 1, column 1, row 2, column 2. Pretty solid, pretty solid, pretty solid. So if our starting row is 0, 0, and our ending row is 10, 0, it is 10 away. You guys concur? 0, 0, 10, 0, it's 10 away. You guys concur? Yeah, all right. What if we started at 0, 0, and we go right 3, and we go down 4? What should we get? So from 0, 0, right 3, down 4. How far away are we now? 5? Sure. Okay. Cool. All right. All right. So far, so good. I think it works, right? No problems here. What if we do something like this? Let's say we're going to be on row 0, column 10, and we're going to 0, 0. How far away is 0, 10 from 0, 0? What do you guys think? How far away is 0, 0, 0, 0, and 0, 10? 10. No. Come on. Please. 10. Talking about 10. It's 4.2 billion. Come on. This is basic mathematics. 10. What about if we went from 3, 4 to 0, 0? How far away is 3, 4 from 0, 0? Yeah, 4. No, not 4.2 billion. 1.7 billion. Clearly. Come on. Come on, guys. Open your eyes. And this is actually a bug that bit me, right? Because I used unsigned, variables for my screen coordinates, right? And my code worked some of the time, and it didn't work some of the time. And I'm like, what the heck is going on here? Well, what's going on here is, let's just subtract the two numbers. This might make it a little more clear. Row 2 minus row 1. Let's just isolate out that, right? You guys understand? It's like that. Just that part of the equation, right? Let's just isolate that. Yeah. You should have known. I don't know what they're teaching kids these days in schools. Computers don't lie. And so, how far apart are 10, 5, and 10? What do you guys think? How far apart is... Oh, no. How far apart are 5 and 10? What do you guys think? 5. Come on. 3.42 billion. It's 5. They're 5 away. 10 minus 5. Come on. So what if we did 5 minus 10? 10 minus 5 is 5. What is 5 minus 10? Right? See what the problem is? 5 minus 10 is supposed to be negative 5. But if you have an unsigned integer, it underflows and it wraps around to maximum integer and then subtracts, off that. Yeah. And so if you happen to have the biggest number first in your subtraction, it works fine. If you have the smallest number first in your subtraction, it underflows every time. And let me tell you, that is a pain to deal with. It is much better under normal circumstances to just use integers for everything. And like the is that confusing you? 10 minus 5 is equal to 5, right? But 5 minus 10 is equal to that, right? If you have unsigned integers, because you cannot have a negative number. You cannot have a negative number with an unsigned integer. It underflows. -1 turns into 4.2 billion and change. And the reason why this exists is so that you do not, this is a feature. This is what it's supposed to do. This is defined behavior. And the reason for that is that if you ever get a negative number, it turns into a really, really, really big positive number. And then your bounds check can catch that. So if you want to find out if like row 2 minus row 1 is within bounds, if it was signed, you'd have to say like if, you'd have to do something like this, like if x is less than 0 or x is greater than 10, something like that. With an unsigned integer, you don't have to do that. You just have to check for that. Because if it's a negative number, it is bigger than 10, right? So it's an optimization, okay? So unsigned integers should only be used as an optimization, in my opinion. And in fact, the standard library, which uses unsigned integers in a lot of places, has actually been moving away from that in modern C++. Size is the one you guys all know and love. Probably it returns an unsigned long on our system. But there's now size. Not size, it's size. You have size and size. Size and size. And size returns assigned size. Returns as positive or negative. Now, can it be negative? No. But the reason why they use a signed integer instead of an unsigned integer is for this issue. Like if you want to find out which vector is bigger, you subtract them, right? And if you subtract them in the smaller ones first, then it underflows. And so they've actually added size to, is it 20 or 23? 20, yeah. It's about 3 years ago they actually added size to the standard library because unsigned integers they create these bugs that are nasty. Like they're really actually like painful bugs. Because my code worked some of the time, and you're like, man, what's going on here? Okay, you guys understand unsigned integers, things like that. So let's take it back to the basics. What kind of types are there? We got int, right? We got int, right? What other values are there that I can put here instead of int? What are our basic built-in types in C++? What do you guys got? What do you got for me? Let's start with integer types. Integral types. Let's hold off on strings and pointers and things like that. What other options we got? We got short. Okay, so we got integer x. We got short s. This is a 16-bit int. This is a 32-bit int. Note, sizes are for our system and are not standard. There is no fixed size for an integer in C++. You can actually go to a different system and find a 16-bit integer, but those machines are all pretty obsolete. Like I haven't seen any of those since like the 90s, maybe the 80s. So okay, so shorts are 16 bits. What else we got? Long, okay. So how many bits is a long? So if integers are 32, how big is a long integer? What do you guys think? And then Mohammed has, we can talk about float. We got float f, got double f2, 32-bit float, and this is a 64-bit float. Long on our system is 32 bits. On Windows, it is 64 bits. So that is not a type I would recommend using because it will actually change sizes depending on which platform you're running it on. I would almost recommend never using a long for that reason. And then we got our long, all right? And this is a 64-bit on both Linux and Windows. Okay. So then we got our floats, which are 32-bit single precision floating point numbers. We got double precision floating point numbers, which take 64 bits each, or 8 bytes. And then we got pointers. Right? So if we have an integer pointer named putter on a 64-bit memory system, it is a 64-bit pointer. If you are on have you guys heard of like 32-bit Windows versus 64-bit Windows? Like when you download things, like it'll, like if you're going to download putty, download putty, You see here how it's like 64-bit, 64-bit, 32-bit, right? If you're on a 32-bit system, pointers are 32 bits, usually. I imagine there's a little asterisk after all of these things, but that's basically what it means. If you're on a 64-bit system, you can address 64 bits of memory, even though you actually can't in a lot of systems. That you don't have 2 to the 64th power RAM, right? And so a lot of the, like it's more of an aspirational, amount of memory you can address. But 32-bit systems is like 4 gigs of RAM, right? So if you're on a 32-bit system, you can't address more than 4 gigs of RAM, which is why Fallout New Vegas, like to this day, like it's my favorite Fallout game, but it's so hard to play because it's a 32-bit executable. It can only address 4 gigs of RAM, and you install mod because you have to install mods, right? It's required, and then they crash because they run out of RAM, and then you try patching it, and it just, yeah. If any game needs a remake, Microsoft, if you're listening to me, Bethesda, Obsidian, talk, make up, become friends again. You guys both work for Microsoft now. Fallout New Vegas remastered, yeah, awesome. Fallout New Vegas 2, even better. Let's do it. I know Obsidian wanted to do it, but I think it was Bethesda that shot it down. Anyway, so yeah, so we are on a 64-bit system on the server right now. So each one of those integer pointers or short pointers, any of the pointers actually, are all 64 bits. So if you have a double pointer named pointer 2, this is also 64 bits. If you have a string pointer, I don't know why you'd have a string pointer. You know how big that is? That's also 64 bits. Because a pointer is an address in memory. That's all a pointer is. It's a spot in RAM. At that memory address, there's a variable. And since you have 64 bits of RAM available, hypothetically, in your system, every pointer is 64 bits wide. So you can point at any point in RAM and be like, that's where my variable's at, right there. Okay. New Vegas 2 is leaked. Whoa. Daggerfall Unity. Yeah. Daggerfall is, in my opinion, maybe the best Elder Scrolls game of all time. And this is a game that, came out 96? 96, yeah. But it's been re-released, so that's exciting. I played a little bit of the beta for Daggerfall Unity when it was in development. So I've actually downloaded it. I haven't started playing it again. But Daggerfall is amazing. Fallout New Vegas also. Incredible game. All right. So what else we got? We got arrays, integer R10. How many bytes is this? How big is this array? How much RAM is this going to get up? We got 10 integers. Can you guys do multiplication? 320 bits, aka 40 bytes. 32 bits is the same thing as 4 bytes, right? There are 8 bits in a byte. Do you know what 4 bits are called? Four bits is called a nibble. Very good, Olson. Half byte is a nibble. Lol. Okay, so yeah, those are kind of like our basic built-in types. Now, string. Now, if I make a string, notice, do you guys see how the string doesn't highlight in green? See that? Like our string pointer isn't green. Our string isn't green. What's going on there? We got all of our types are green, right? Why is string not green? Hashtag include string. All right, do that. It's already included, actually. It's included transitively. I include read, read includes IOStream, IOStream includes string. So it's been transitively included already. By the way, it doesn't hurt anything if you do this. If you even if you were to like copy and paste it like a bunch of times, I shouldn't say never, but it like in the standard library, it's never gonna. Let's just go to the definition. Nope. Is that not installed? Either way. At the top of a header file, it's going to have something that prevents it from... What's that? Anything you want, girl. My plugins aren't working. Weird. Okay, anyhow. At the top of a header file, there's going to be something that prevents it from being included multiple times. That is your bean and cheese burrito, yes. Okay, but that's not why string is not green. Why is string not green? It's because it is not a basic type. It's not part of the language. It's part of the standard library. So things that are part of the standard library don't get highlighted in green. They just aren't cool like that. So if you do something like a vector, events, and vec, notice the int gets highlighted in green because it's a built-in type. Vector does not. These are actually added on. The standard library builds them out of the basic blocks of the language. What if you want to specify how many bits you want? You know what I mean? Like instead of a long, you're like, I want 32 bits. Do you guys know how to do that? Like even int is not guaranteed to be 32 bits. What if you need 32 bits? Like you need the values to range from -2 billion to +2 billion. How do you tell it, give me a 32-bit integer? You guys know how to do that? There is something called I told you, we're reviewing CSCI 40, but we're also maybe learning some new stuff today. This is something called standard integer, okay? And inside of standard integer, there are things like int 32_type. And there is unsigned integer 64 type named y2. Okay. And so this is a 32-bit int, and this is a 64-bit unsigned int. You guys see that? So this is actually probably good practice. You're probably not going to get surprised these days by having an int suddenly turn into a 16-bit number when you move between systems. Like if you port your game to the PlayStation or Xbox, it's like I haven't heard of any. I could be wrong, by the way. Like I'm sure there's something out there, but none of the systems I've used since the 90s have had 16-bit integers in them. Maybe the 80s. But if you're using a long, that switches sizes depending on what platform you're on. And so it's a lot better, like, I want 32 bits, or I want 64 bits, or, you know what I mean? And so, in my opinion, it's good practice to just tell C++, I want a 16-bit number, I want a 8-bit number, I want a 32-bit number, rather than using char and short and int and things like that. And in fact, in game dev, these things will usually be aliased. They'll have something like using u32 equals uint 32 keep, and then they'll just have like variables like this. You guys see that? So make an unsigned 32-bit, make a, and so they just have aliases for everything. And so every variable you have will say whether it's signed or unsigned and how many bits it is. So instead of using long, which is dangerous because it could be 32 bits, could be 64 bits, you always tell it signed or unsigned, how many bits, done. The only downside is you don't get the cool little green highlighting, because it's an aliased type. So this is how you can like alias a type, by the way. Have you guys seen this before? Have you guys seen that? Aliasing a type. You're gonna make your own type. It's the same type, but it's less typing. So you can type a new type, so you can type less. Yeah. So yeah, if you wanna like hate people reading your code, you like using swag equals int. Do swag score. if you want. And people will get so annoyed at you for what is swag? All right. So this is how you can make 10 integers. If you want to make 10 integers using vec, you can do it like that. So this makes 10 integers in a vector. Note, never use a C style array. Okay. If you want a pro tip, never use a C style array in your code. There's just no reason to. You can use a vector, or you can use a C++ style array. C++ style array is found in hashtag include array, like this. And you can say an array of integers of size 10 named R2. And so what are the benefits of this? Let's say that you wanted to set all the elements of R and R2 to be some number. Okay. For int I equals 0, I is less than 10, I plus plus, R square bracket I equals 42. So this code here, that code is setting all of the elements of R to be 42. Do you guys concur? Seems fine? Okay. I have an issue with it. And the issue is, what about now? Am I setting all the elements in R to 42 now? Yeah. So every place where I had a 10, I need to change it to a 20 now. So I could use a constant called R size equals 10 and make sure that I use R size, which is great, except, what if I have two arrays? Now I have R size 1, R size 2, R size 3, R size 4. My lord, that's a pain. Wouldn't it be nice if just the array could, constant, sorry. Wouldn't it be nice if, like, your array could just keep track of its size? That would be cool, right? That would be neat. Another way you can do it with C-style arrays is you can do this. What is the size of the array divided by the size of an integer? And so the array is 40 bytes. The size of an integer is 4 bytes. 40 divided by 4 is 10. So that is how many elements are in the array. Which also doesn't work once you pass an array to a function. If you pass an array to a function, it loses its size information. It's just, don't ever use a C-style array. It's just a very simple principle to follow. For whatever reason, people love their C-style arrays. They just have so many issues with them that you don't need to deal with. Like, watch this. Watch how nice this is. So we've got our array 2 here. It's a C++ style array. Watch this. For int I equals 0, I is less than R2.size, I plus plus. R2 square bracket I equals 42. Isn't that nice? It actually knows how big it is. So you don't have to do weird hacks like this that only work in the local scope. Once you pass it to a function, you can't do that anymore. But if you pass R2 to a function, you can always call .size on it. It works. It's fine. Okay? So, yeah. Or, the other way that I was showing you where you have a constant for the size of the array, which is fine if you have a tiny little program. But if you've got 50 arrays and each one of them has their own constant array size, like, what? Like, a lot of people just make all their arrays all the same size. Everything is 80. How big is the string? 80 characters. How big is your array? 80. Why? I don't know. Just is. Everything's 80. And the code works right up until you need to store 81 numbers, and then all hell breaks loose. Okay, So, have you guys seen C++ style arrays before? Nope. Yeah. They're nicer. They're just like a C style array. They're just better. And I prefer vectors over arrays anyway. Most of the time, arrays are fixed size. Vectors can grow. Vectors are probably a little bit slower, if that matters. So there are times where, as like an optimization, you'd want to use an array instead of a vector. In general, though, I just use vectors for everything at the beginning. And then once I decide I need something else, then I switch them out to something else. Vectors are life. Okay, so that's all the different types we need to worry about in C++. Let's look at algebra. What kind of algebra is available? Integer x equals 10. Integer y is equal to 20. C out x plus y. Addition, subtraction, multiplication, and division. And what's the fifth one? What's the fifth operation? Not question mark. What is it? Modulus, the remainder operator. Okay. So what is 10 divided by 20? Quick, pop quiz. What is 10 divided by 20? 0. Very good. No, it's a half. No. These are integers. Whenever you do integer division, if you have two integers, you get an integer as the result, right? Two integers go in, one integer comes out. Welcome to the Thunderdome, right? The name of this class. So 2 men enter, 1 man leave, right? So 10 divided by 20, they're both integers. When you divide 10 by 20, 20 divides into 10 0 times, with a remainder of 10. So 10 divided by 20 is 0, with a remainder of 10. What about exponentiation? What is 10? What is 10 to the 20th power? Why is your professor looking at you like that? It's 30. Come on. You guys know this. It's 30. The caret operator is not exponentiation. The caret operator, by the way, the shift 6, is bitwise XOR. It is not exponentiation. How do we do exponentiation? How do we do an exponent in C++? Pow. You're right. Hit the pow block. Pow of x to the y. Pow. And that is, yeah, big old number. Okay. How do we do square root? Square. SQRT. Very good. Square root of x. Square root of 10 is 3.1. Yeah, okay. 3.1-ish. Good. Yeah, sounds about right. Okay. Subtraction, multiplication, division. What if we made these floats or doubles? Which one of these? And let's pull out the fake exponent. Which one of these lines of code will not compile once I switch out the integers with, let's say, doubles or floats or whatever? Which one of these operations can you not do on a float? Mod is correct, because you never have a remainder when you do floating point numbers, right? Boop. Not allowed. Cool. All right, so, and we could even make these into proper floating numbers. Okay. Absolute value, that's another thing. Make this a negative. See out. What is the function for absolute value in C++? Abs. Okay. So in C++, you can have two functions with the same name. It's called function overloading. Okay? As long as their parameter types are different, you can overload on them. In C, though, you can't have two functions with the same name. So abs is the integer version of absolute value. Does anyone know what the double version or the floating point version is of abs in the C library? Fabs. So is fabs for floats or is fabs for doubles? Is that the floating point version of abs or is that the double version of abs? Because those are different. What do you guys think? Float? Float? It would make sense, right? The double version should be called dabs, right? There is no dabs. The double version is called fabs. The float version is called fabs F. Students are visibly sighing on Discord. Yeah, I don't know who named these things, man. I assume at some point they just got in too deep. They're like, we're gonna have ints, we're gonna have doubles, that's it. And since doubles are floating point, it'll be fabs. And then at some point somebody's like, we need a float version of it. And they're like, well, why don't we call it fabs? And like, that's too many Fs. Let's put the F at the end instead. And there's different versions of his too. There's Fabs 64X and yeah, okay. But we don't the utter rapscallion tomfoolery clap, yeah. So yeah, the good news is in C++ we don't have to worry about that nonsense because everything is just apps. Okay. That's algebra. Let's do some if statements. So let's do some catchphrases. So if some of you guys want to put your catchphrase up on Discord, I will put your catchphrase into a program and memorialize it forever, or at least until we get to the next section. I delete it. So, all right. So Marsh has okay. All right. So string s is equal to read. What is your name? And we'll say if s equals to Marsh, then we will see out the utter rapscallionry. It's a great catchphrase, I have to say. Great catchphrase. Now, some people, some professors even, will say always put curly braces every time you do an if statement or an else statement or an if else statement. There's some good reasons for that. I don't like it. It spreads out your code too much. It's something that people get heated about in debate. Personally, if it looks clean, then I don't put them in. At some point, when the code gets too big, then yeah, I'll make sure they have curly boys in there. But all right, so else if the string is equal to yeah. It is a terrible day for rain. Okay. Else if s is double equal to bean. And Medina. Light work baby. Now, a student in the previous class asked, is there a difference between using \n and inline? The short answer is no. The long answer is yes. So first of all, you can embed a new line into a string, right? So like for the read function, which takes a string as a parameter, you can embed a new line into it by using \n. You can't put an inline into it there. So that's one obvious difference. It's actually part of the string. You can put new lines inside of the string as many times as you want. The more technical difference between ending a output like that and ending it like that is if you're outputting to the console, like the screen like we have here, there's no difference. They're exactly the same. But if you're writing to a file, there's actually a very important difference. Every time you write to a file and you do an inline, it flushes the disk. If you've ever like saved a file in Microsoft Word and you hit save, it just goes like this: saved, done, instantly. But what's actually happening under the hood is that it just took your file and put it into a chunk of RAM, and then over time, the operating system is going to write out all that data to disk. So if you hit save in Word and it's like done, don't turn off your computer. It's a bad idea. Don't be like, I'm like one of my friends did in grad school. I'm done, and hits the power button, and then the thesis vanished. Right? Don't do that. I'm done. No, because it's not actually written to disk. And so when you do an inline like this, it actually waits. It basically syncs with the disk and waits for the disk write to finish. And so if you do inline over and over and over again, it is going to destroy your performance if you're writing to disk, because it'll keep waiting for the write to finish. Whereas if you use new line like this, it'll just toss it all into an output buffer. And then maybe at the end of the day, you might do like a cout.flush or something like that. And that will flush it all to disk and make sure it's all written. Now, the downside to doing this is that if your code crashes and you have data in the output buffer like that, that's invisible, you can't see it, it won't appear on disk, right? So if your code's crashing, you really want to make sure you are using inline and or flush to make sure all of your output statements appear on disk. Because if you don't do that, you might be like couting, I'm here, I'm here, I'm here. And your code crashes, and it might have printed all of those things out, but they don't appear on disk. And so you might think, oh, I'm crashing way up here. No. You're crashing down here. Just all these cout statements have vanished because they're in this output buffer. Have you guys ever gotten yelled at by Windows for like unplugging a USB drive? Like you got a little like USB drive or something, and you just like pull it out, and Windows like, you do not unmount the file, like, you're supposed to go to the thing and you got to eject it safely. Yeah. Yeah, that's all nonsense. You actually don't have to. And the reason for that is because, in fact, I'll probably demonstrate this to you. I mean, they're doing that as a safety thing. They're doing it as a safety thing. Like they're trying to educate people and keep them from like just, destroying their data. But I can demonstrate this to you. Let's see here. Thumbelina is the name of the drive. Okay, so we got Thumbelina here. And if we go to hardware, let's see here. Tools. There it is. Okay. So this is my SSD. This isn't Thumbelina, but whatever. So you see how there's this thing called write caching? Okay. So write caching means when you write a file, it actually goes into RAM, right? And then it'll write out to disks afterwards. So it speeds up your writes. But if you crash, if you turn off your computer, you lose power, that data vanishes. And so with a thumb drive, all the thumb drives by default have this turned off. Okay. And so that's why when you copy a file to a thumb drive, you'll see the progress bar going dong 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 like that, because that's actually it copying it to the drive. And so when it finishes, you can unplug it. Not a big deal. I usually pause, like after I copy a file over, I take a breath, I go, and then I unplug it. And Windows will oftentimes yell at you, but if it's just there in case somebody was dumb enough to turn write caching on their thumb drive, then they would lose data, right? And so on all thumb drives that I've seen, write caching is disabled. So when the write finishes, it's done, right? But if you really want to be safe, sure, go ahead, eject safely. That'll make sure that everything's been flushed the disk properly. Yep. Yeah, that's the face my friend made when they lost their piece. Okay, so that is somebody's. That's called Nan. Okay, so you guys know about Nan, the war in Nan. Right? No. Not a number, right? So you can have float f is equal to Nan. Yeah. You get that if you divide by 0, right? Print out Nan. You'll see that in Canvas. The average score for the class, Nan, right? You'll see Nans everywhere, right? What if you add 10 to Nan? What do you get? What do you think 10 plus Nan is? Fortunate Son playing in the background. Nan, yeah. Yeah, so basically Nan, if you add any numbers with Nan, subtract, divide, comparisons always fail, you know. Comparisons with Nan are always false, which you could be like, you know, if f is less than 0, or f is greater than 0, or f is equal to 0, see out high, else see out by. What do you think this is going to print? By. Right? You would think, right? Like looking at that, if the variable is greater than 0, or less than 0, or equal to 0, that covers all of the possibilities. Wrong. So this is why people get Nan flashbacks, right? Because like I've covered every possibility. It's either bigger or smaller or equal. Nope. It could be Nan also. Floating point numbers can also be positive 0, or they could be negative 0. Ada, did you hear that?
What?
What?
What did you say?
You can have positive 0, or you can have negative 0.
But
what?
There's just nothingness.
Huh?
There's nothingness.
So if x is positive 0 and y is an odd integer, the result is positive 0. If x is 0 and y is greater than 0, if x is negative infinity and y odd integer, negative infinity, and if x is positive 0 or negative 0 and y is an odd integer less than 0, pole error occurs, and huge val half with the same sign as x. So the same sign as the 0 gets returned. So if you have positive 0, you get a huge positive value. If you have a negative 0, you get a huge negative value. So yeah, floating point numbers suck. They are really, really annoying to work with. Because you think you know, like, oh, they got decimals on them. You know, it's like an int with decimals. Nope. There's a lot of weird things in the IEEE 754 format, as I was calling. Yeah. So there is a standard for floating point numbers, and there is a lot of in addition to Nan, there's positive and negative infinity. There's a signaling Nan and a quiet Nan. It is really annoying to deal with. So my calculus instructor was in fact a Nan wrangler. So he worked for General Dynamics back in the 80s and 90s, and his job was to look for where numbers would get very close to 0. So if you divided by them, they could turn into Nan accidentally. And if you add anything to Nan, that turns into Nan. And so like if you set one person to be the average of its neighbors and one of them's Nan, then it becomes Nan. And and then the next frame, that guy becomes nan, and that guy becomes nan, and that guy becomes nan, and nan spread through your code like viruses. It was his job in the code base to like look at every place there's a division and stare at it and be like, could that turn into a nan somehow? Like, every frame you got friction, like you got velocity, but you got friction. So every frame it slows down a little bit. 5 divided by 2 is 2.5, divided by 2 is 1.25, divided by 2 is 0.6, divided by 2. But you divide by 2 enough times, that turns into a number very close to 0, and then you get a nan as a result. And so that was his job. He wasn't a calculus teacher full time. He taught calculus for fun. His full-time job was a computer science guy, doing numerical simulations, things like that. So anyhow, so we were here with our if, else if, else if, else if, and we need an else, of course. We need an else. Else cout, I don't know you. And we can also throw a Mincarelli in here, of course. Else if s is equal to Mincarelli. Mincarelli on right now. No, he's gone again. So we will just see out a little goat, maybe. Let's do a little goat emoji for Mincarelli. There we go. Okay. All right, so what is your name? Mincarelli. Prints out the goat. We print out good. Okay. So in C++, you got if, you got else, you got else if, and you can string these things together like this. And the way that it works is that it goes down one at a time. Like a very common way that I get students, in other words, they get the question wrong, is I'll add like a second bean, like a second bean. Formatting on this one. Yeah. Right, so there's 2 beans, right? Okay. And so if I type in bean now, which one is it going to print? So if I say, what is your name? And the user types in bean, is it going to say it's a terrible day for rain, or is it going to say it's a good day for rain? Or both? Which one? Actually, I do know. But, yeah. What do you guys think? A very specialized job. Yeah, but I mean, honestly, he did a really good job teaching me how to use computer science to solve math problems. He was not a good math instructor. Because math instructors teach you how to solve things directly. You integrate, you use these equations, and he's like, look, at a certain point, math gets too complicated, and you approximate a solution. So I got really good at approximating solutions. I didn't get very good at directly solving equations, which hurt me later on in my calculus career. But then after my calculus career was over, and I went into the real world, knowing how to approximate solutions, turns out he was right. It's far more useful being able to approximate, a differential equation than it is to directly solve it. You can only directly solve kind of simple stuff. It'll be the first one, and then none of the statements after. That is correct. Because when you have an if statement, it goes one at a time. Is it bean? No. Is it bean? No. Is it bean? Yes. So it prints out everything between the curly boys, and then skips over all the rest and does the flush down here. Again, the curly braces can be there. They don't have to be there. If you have a single line of code, the curly braces are optional. And that's something a lot of students get wrong too. You don't have to have curly braces when you got one line of code. But a lot of professors will say, always put it in there just in case you want to do something like this, right? Like have a second line. If you didn't have the curly braces, then all of a sudden everything breaks. If else if. In the previous class, somebody asked about switch statements. Switch statements I dislike intensely. Switch statements are like unsigned variables. They're there as an optimization. Okay, so let me show you Duff's device. I've shown this to you guys before. Duff's device. Look at this for a second. So we got a little bit of algebra going on here. We got a variable. We're adding 7 divided by 8, modulusing by 8. Olson, what is this code doing? How is it that we have a beginning of a do loop, do while loop, in the middle of a case? If count modulus 8 is 0, there's actually an open curly brace inside of that that matches a closed curly brace outside of all the cases. Yeah. So want to do all the cases down the list. Yeah, if the thing is 5, it'll do this, then it'll do this, then it'll do this, then it'll do this, do this, and then you've got the ending of a do while loop that doesn't have this in it. How do you have the ending of a do while loop without the beginning of the do while loop? We skipped that, remember? Yeah, this is why I don't like switch statements. I hang out a lot on the CPP questions subreddit. Every time a new programmer uses a switch, I immediately look at it, and half the time the problem is in their switch statement. If you forget a break, things like that. So string. You also can't use it in a case like this. Switches only work with integers, right? So if you have integer x is equal to 3, we say switch x case 1 cout I you'll see this code. This is bad code, by the way. You'll see this code all the time from new programmers. So what is this going to print to the screen? X is equal to 3. Switches only work with integers. In C# and other languages, I think they're a little bit more flexible, but you couldn't even do this like with margin, say in Bean with a switch. What is this going to print? Yeah, people typing. Try and Y is correct, yeah. And so people forget the breaks all the time in this. That's like the most common mistake I see people make. They forget the breaks. It also breaks the language. Like this syntax here with a colon is only used in one other place and nowhere else. That place would be here. With a goto statement. Because goto statements are in C++. Only other time the colon is used. Okay. So what is this line? What is this highlighted line of code here going to do? What do you say? URL, right? Is it going to compile? What's it going to do? Yeah. So let's run this. Okay. I just made my own loop. Who needs while loops? Who needs do while loops? Who needs for loops? When I got goto. Right. So if I type in Olson, I don't know you. Mincarelli. Goat. What's your name? Sia. Bean. Or an infinite loop. So we just made our own loop because this is a label. Okay. So a word with a colon after it is a label. It labels a line of code. The part here about the Google is actually a comment. It's // right? That's a comment. Doesn't do anything. When you say go to HTTP, that will jump to whatever line has that label on it. This is a do-it-yourself loop, infinite loop. And you might be like, oh, well, let's break out of it if we type in Mincarelli. Guess what? You can't. You can't break out of it. Why? Because we're not in a control structure. We're not in a while loop. We made a while true loop. You can't leave it. Can't leave it. There's no while loop. You can't break out of anything. There's no loop. So don't do this. Don't use gotos. They're terrible. Instead, if you want to make a loop, while true. Okay. And now, watch this, by the way. If I want to see how the formatting is all screwed up, because it needs to be pulled in, indented one, watch this. Equal sign, shift 5. Boom. You guys like that? Equal sign, shift 5. Equal sign is the reformat command. So if your formatting is all screwed up, equals equals, bum bum, it'll put it in the right place. And it can take a motion, and so like if we have like 5 lines that are not indented properly, that could be like equals 5. Sorry, 5 equals equals, and then that will indent the next 5 lines. That shift 5 there means jump to matching curly boy. Okay, so if you want to know where the bottom of main is, shift 5, boom, there you are. This is really useful if you have a really big loop and you want to go to the bottom of the loop and see what's after it. You can just shift 5, you see it's jumping up and down there. Yep. So, while true loops we use when we don't know how many times the user is going to do something before they quit. Right? If you have a video game, you use a while true loop. Right? If you're Mojang, you don't know how long somebody is going to play Minecraft for. Right? They have a while true loop, and inside of the while true loop, they're going to read from the keyboard and the mouse and update the screen and move monsters around and play sounds and things like that. And it's just going to keep going and going and going until the user hits quit. When the user hits quit, they break out of the infinite loop. So this is the pattern. You have a while true, and then somewhere within it, you have a break, or maybe rarely you have like an exit where it quits the program, right? Which works too. If you know how many times the loop is going to run, you use a for loop. So I've seen a lot of people try some really crazy looking for loops for 99 bottles of beer. Remember, for 99 bottles of beer, if the user says 4 verses, you say 99 bottles of beer on the wall, 98 bottles of beer, 97, 96, you're done. You count downwards always from 99. And so people have tried doing things like this, like for int I equals 99, I is greater than or equal to 0, I minus minus, C out I, and that'll, give you 99 down to 0, but it's not like, okay, well, these are types in a verse, and so they're like, okay, well, we'll do minus verses, I guess, verses equals read. So now, if we do 5 verses, wait, that didn't work. It starts at 94 bottles of beer and goes down to 0. Wait, that's not right. And so they'll sit there and like just mess with this for loop. And for me, there is a pattern you follow when you do a for loop. For int I equals 0, I is less than blah, I plus plus. And whatever you put in there for blah, that is how many times the for loop runs. This is a pattern. I don't have to count on my fingers and toes. I don't have to be like, okay, it's 99 minus 7, and it's counting down. Does it include 0? Does it not include 0? Okay, so if the number is 7, 92 is the first one. Like, if you make me think like that, I'm probably going to get it wrong, okay? And I'm going to, you don't want people to have to think when they code. You want it to just be automatic. If you ever show an experienced programmer this for loop here, they don't have to think about it. They don't have to count on their fingers and toes how many times this for loop runs. This for loop runs 10 times. This is the pattern you're going to use in about 90% of all for loops you write. Okay? Sometimes people are like, well, I could start counting from 1 and go up to less than or equal to 10, and that's still 10 iterations. Yeah, but don't. And the reason for that is because the half-open code pattern that I teach everybody matches the indices of a vector of size 10. Okay, a vector of size 10 starts at index 0 and it goes up to index 9. And so this pattern you will see over and over and over again in C++. Now, if you're used to a language that starts at 1 or something, then yeah, I would use the other pattern. But in C++, we start counting at 0, and so this is the way. This is how you do it. Okay, so if we have verses, that's how many times we're going to loop, right? So for 99 bottles, if the guy says I want 10 verses, you put a 10 in there, it's going to run 10 times. So how do we get it to count down? Well, we use the powers of algebra. 99 minus I. 99 minus I. Bottles of non-alcoholic beer. Yep. So if we type in 5 verses, then we get 5 verses. Look at that. And it counts down from 99 to however many verses we have. Yep. So that is how I would do the 99 bottles of beer assignment. Okay. Use algebra inside of the for loop. The actual the control structure itself, I almost always follow the pattern. Not always. It's not 100%. It's not even 95%. I would say it's about 90% of the time you will see me write a for loop exactly using this pattern, where the only thing that changes is how many times the loop runs. Okay? You guys all got that? You guys know range-based for loops? How many people here have never seen a range-based for loop before in their entire life? Range-based for loops. Printing out all the elements in a vector, that kind of thing. You've not heard of it. All right, cool. So, vector of integers named vec. 10, 20, 30, negative 100, 1000. For every integer in the vector, see out that integer. Simple, easy, clean. Okay. You could use a regular for loop for it, but it's more typing. And range-based for loops are nice because they can never go out of bounds. It will figure out the bounds on its own. You don't have to worry about what index you're in ever. The first time through the loop, x here is set to 10. The next time through the loop, x is set to 20. You'll sometimes hear these called for each loops. Like if you've done Python before, it's like a for each loop. For each element in the vector, do something. Does that make sense? So for each integer in the vector, print out that integer. Does that conceptually make sense? So for each integer in the vector, print it out. So print out 10, then 20, and then 30. Okay. You like it? So yeah. I like it? Jelly? Kind of cool. Yeah. Now, it's limited. We only use these if we are going to iterate across the entire vector. If you want to just like print out the first 7, can't. Yeah, you could hack it together, but we don't use range-based for loops for that. If you want to know what index you're on, again, you can kind of hack it, but we don't use it for that. So like if you wanted to print out something like this, where you're like outing, index I is equal to, something, vector.at I, then we would use a traditional for loop for that. Because a traditional for loop is going to give you the index of each element as you come to it. So, one range-based for loop. 2 traditional for loop. Traditional for loop gives you a little bit more power. You can choose to start, on 10. You can end halfway. You can plus equals 2 and print every other element. You have more power, more control with a traditional for loop, but you also run the risk of going out of bounds. Okay. So not much of a risk here because we're just printing every element. But, if you start messing with it, like that, now you're going to go out of bounds. No, you're out of bounds. No, you're out of bounds. What's going to happen? First of all, let me show it to you working properly. You can see they do exactly the same thing. except with the traditional for loop, we can get the index and print that out. The range-based for loop, we don't really have that. Again, we could hack something together. We could keep a counter or something, but then at that point, you're just doing this anyway. So. Actually, before we get to going out of bounds, what if I did this? X plus equals 10. What is this going to do? For every element in the vector, increase its value by 10. What is this going to do? Nothing is correct. If you want to change a vector using a range-based for loop, this is something everyone forgets. You have to put an ampersand there. Okay. Use an ampersand if you are going to change. Okay. So that'll increase the value of every element of the vector by 10. Very simple, right? Boom. Everything's up by 10. Done. Like range-based for loops I love. They're great. And we use them. See, the first element's now 20, then 30, then 40. Whereas before they were 10, 20, 30. I love them. Because most of the time, yeah, we just do loop over the entire vector and do the same thing to every element of the vector. And so they're great. But, sometimes, sometimes you want to print out the index because you want to know where you are. Stuff like that. So what if we wanted to print I minus 1? What is this going to do? What's going to happen when we try accessing elements 1 to the left? What's going to happen here? Negative 101 is considered out of bounds. It's just going to be negative 1. Right? Because the first iteration through, I is 0. 0 minus 1 is negative 1. Negative 1 is out of bounds. And so it crashes, which is good. It tells you you made a mistake, which is good. You do not want it accessing RAM outside of its boundary. Okay, so it throws an exception, stood out of range, and we tried accessing element 1.8 pentillion or something. Wait, I thought we were accessing element negative 1. Why is it printing 1.8 pentillion? You guys remember this from the beginning of the lecture? The rows and columns and things like that? Underflow, that's correct. The index is a size underscore t, which on our system is an unsigned long. It's an unsigned 64-bit integer. We passed in negative 1. It underflows up to maximum integer for a 64-bit number, which is a big number. And then, that's what negative 1 is equal to, obviously. Yeah, I knew that off the top of my head. You didn't even have to tell me. But like, if you ever see a number like that, you might, well, I'm not accessing 1.8 pentillion. What are you talking about? But now that you know. There you go. And so this is good. And so the size check only has to check to see if the number's bigger than 5, right? Because we use an unsigned integer, it doesn't have to check for you accessing a negative number, because a negative number automatically underflows up to a big number, and then the check for are they accessing 5 or above catches it. So it's an optimization. Okay. But you do get weird error messages, right? Okay, so what if we used square brackets instead of dot at? What's the difference between square brackets and dot at? Is this still going to crash? Is it going to die? Is it going to print something? Is it going to warn us? Dot at has bounds checking. Square brackets do not. Okay. Yeah, so it accessed 0 for now. If we run it again, we're getting zeros. It'll always be 0. It will never not be 0, right? Right? We can guarantee, in fact, the vector will always have a 0 in memory before it in RAM, right? We can count on this being 0 because I've run it 5 times And every time it's been 0. It's just a rule. I don't know if they believe me, Ada.
But
I don't know if they believe me. No. Yeah, in fact, it might be 0 every time you run it. And then 5 years from now, the system might update, and all of a sudden you get 20,000 there. And if these were like voltages you're putting out into an automatic defibrillator, you kill somebody. And nobody will know why. Because you're accessing random memory. Your code runs differently. And you have no record of it. This is why I tell my students never use square brackets in this class. Okay? Always, always, always use .at. So if you do something wrong, you screw up, it kills your program, it tells you that you done goofed, right? And you can fix it. It's nice. Okay? Don't ever use square brackets in this class. Square brackets are an optimization. And just like with unsigned integers, just like, these other things I've talked about, switch statements, they're there. I just don't teach my students to use them because I want my students to be slow and safe to begin with. You should always start slow and safe. And then once you get your code working and you're not going out of bounds probably, then I give you permission to replace the .ats with square brackets, right? If you need it. You're probably not going to need it in this class. There's not many assignments where you're going to time out because you use .at instead of square bracket, right? There might be one, but probably not. Probably not many. Okay. Always start slow and safe, and then go fast and dangerous if you need the speed. Okay. You guys understand? So don't use C-style arrays. Don't use square brackets. Don't use switch statements. Don't use unsigned integers. Like, keep it safe, readable, bug-free. Okay. Something tells me that it won't always be 0. Yeah. It won't. If we do this with an, I don't know, switch it out, maybe integer array and like if we did this with R instead. Yeah, see, there you go. Deliver 32,000 volts. We went off the end too. We went off both ends. The array is only size 3. So right before R, we got 32,000. Right after R, we got negative 100. You should never in the course of your program ever see these kinds of numbers. Never have uninitialized variables. Never have square brackets. Always bounds check. You know anything? You know what I'm saying? You guys with me on this? Like, I never want to see code like this. All right. I'm in an unbearable pain. Yeah, exactly. Okay. All right. Functions, IO loops, if statements. Let's talk a little bit about functions. We'll call it a day. We got like 4 minutes left. So I like functions like this. The one part that students sometimes have trouble with is like you can have functions that don't return a value, so they don't behave like functions in algebra. And so this function here will just print hello world or something. All right. Call hello. It just prints hello world. What happens if I try catching the return value of this? What do you guys think? What if I say integer x is equal to hello? Is that going to work? No, can't do it. Void functions do not return a value. You cannot catch the return value. Okay. The other thing that students have trouble with sometimes is call by reference. So we could do a pythag. Let's just do int by reference C, int A, int B. Remember in C++, it's okay for 2 different functions to have the same name as long as the parameter list is different. So I could do like int C is equal to hypot 3, 4. C out C. iPod is the Pythagorean theorem. So what is this going to print to the screen? Got 2 minutes. It's going to print. Error? No. 5. Good. All right. Prints 5. Good. All right. Now, if we wanted to do this in a non-functional way, which I don't recommend, this is a non-functional function. I mean, it functions, but it's not functional. We could do it like this instead. Integer C. And of course, I'm always going to initialize it. Pythag C3, 4. Okay. So what's happening here is instead of returning a value like we probably should, philosophically speaking, we are setting... Oh, let's maybe actually write the code. C is equal to square root of A times A plus A times A plus B times B. Like that. So rather than returning a value, we are setting the value of C to be the sum of the square root of the sum of the squares of A and B. Okay. So this is functionally the exact same thing, but it's not a function. It's not like an algebraic function. When you have algebraic functions, when you have algebraic functions, it still works. They're nice because you can composite them together, right? If you had like hypot 3, 4, that returns 5. And if we wanted to, we could feed that into pow. We could like square it, you know what I mean? And then, you know, if we wanted to, we could, I don't know, absolute value it. I mean, it's already positive, but you know what I mean? Like when you have a function, you can put a function inside of a function, and composite the functions together. And there's no side effects, which makes it easier to reason about, things like that. So I don't like writing code like that, but, you know, some people do. In fact, when you see cn into, you know, when you see a cn, that's technically a call by reference function. It doesn't return the value of C. It returns cn. It doesn't return the value of C. That's why my read library is better than the standard library, because it is a function. You call read, and it passes a value back to you. Cool. And so you could read, you know, you'd be like integer C is equal to read an integer, and we're going to square the result. How? Right? And I don't know, we'll cube the result and absolute value. Can't do that with cn. You guys understand? But my read function just passes the value back. So 3 cubed is 27, absolute valued 27. Are you guys with me? So in general, when you write a function, you want it to be functional. Not functional like it works, but like functional like algebra. Like it takes parameters in, if possible. You know, there's always exceptions. If possible, you take parameters in, you do some computations. Here we're doing, you know, a couple subtractions, a couple squares, do some computations, and you pass the value back. That's sort of the ideal for a function. To me, people will disagree on that, but I like my functions being like algebraic functions. Because you can composite them, and there's no side effects. Like there's nothing here that is affecting global state. It's not affecting variables in main like our earlier version did. It's changing something outside of its scope. It makes it a lot easier to debug and to reason about and things like that. They call them procedures. Yeah, a void function is a procedure. Yeah. Or you can call it a subroutine. Yeah, but they're not functions in the way that I like to make functions. So, yeah, I don't like this. All right, so that's it for today, guys. Do you guys feel like, you know, maybe you learned some things? Like, even though we kind of reviewed all of CSCI 40 in one class, do you feel like, you know, maybe you picked up some skill points in C++, picked up a little philosophy of coding, learned about switches and why they suck, go-to statements, why they suck? Uh, you reintroduce the C++ style array to your brain. Yeah, I didn't really talk about it in 40. Maybe I did, but not really, because vectors are kind of better. There's a place for C++ style arrays, which is if you have a function that's being called millions of times a second, constantly recreating a vector involves a call to a new and delete every time, and it can be slow. So again, arrays are an optimization, but I would just start with a vector, and then if you need the speed, then like I said, then you can reason about it and be like, all right, we'll replace the vector because it's always size 5, so we'll replace the vector with an array. It'll be faster to initialize than uninitialize. Yeah. You can, but in general, vectors are like the vanilla ice cream. You just kind of use it until you need to kick it up a notch. We only use Visual Studio in my C++ class, so Putty and Vim and all this are very new. Yeah, but don't be too afraid of Putty and Vim. Learning Unix is really it's a really important skill. UC Santa Cruz actually didn't used to articulate our classes because we didn't say that we used Unix. Like a lot of the UCs actually want you to have Unix skills before you transfer. And so now's the time. If you're not going to learn, in college, like you're probably never going to learn. College is a time for experimentation. And by experimentation, we mean Unix. Vim is life. Once you know all the, nobody knows all the Vim commands, but once you know the Vim commands, coding any other way is like walking through mud. It just really does make you more productive. And if you're going to be a computer science major, and you're going to be coding the rest of your life, yeah, spend the time to learn Vim. The way that I did it was I had on my wall in my dorm a Vim cheat sheet. And every day I would look at it and I would sort of metaphorically throw a dart at the wall. I didn't have darts, but I was just kind of like looking at it, be like, all right, today I'm going to learn the S command. What does the S command do? And I'll be like, all right, S. What? Let's try that again. S. Okay, it deleted a letter and put me into insert mode. Why the hell would I want to do that? I could just type X and I. Why should I use that? But then, let me show you something. 3S, let's change them from ints to shorts. Watch this. Dot. Dot. Dot repeats the last command you did. So 3S deletes 3 letters and puts you into insert mode. Type short, escape. It saves that into an automatic macro. And so you just mouse over, the next thing, dot. Easy. Like I told you, Vim's like lightning. So, you don't know how to use the command input tester. So if you, are you on the system? Oh, okay. So if you are in here, and let's maybe not out your code, but let's run it. 1 verse, 2 verses. Okay, well, 99, no. 100, no. Oh, okay. Well, your code is working for 100 and the error cases, I guess. So you're probably going to pass 3 test cases. Let's find out. So from your 99 bottles directory, you type input tester, hit return, and enter your email. It doesn't matter. a@b.com. Username, whatever. And then you can see it'll compare the code that you have on the left-hand side with the correct code on the right-hand side. And it highlights the difference. So you misspelled 1, right? So you are failing this test case because you have a typo, right? And so the input tester will tell you, hey, you need to put in the letter E here, right? And then if you pass a test, well, we just scroll past. If you pass a test, it'll say test passed, test passed, test passed. And so you're done with the homework when you get all tests passed. So just from your 99 bottles directory, type input tester. And what you want to see is test pass, test pass, test pass. Okay. So that is it for today, guys. I got a shrimp burrito from Rubio's tempting me with its delicious aroma this whole time I've been talking to you. So once it is done, you don't have to turn it in. Yeah, what I do is this. I type in sudo collect homework CSCI 41 99 bottles like that, and it copies all of your code out, copies it into a archive of every homework turned in ever, which we use for cheat detection. It compiles it using your credentials. It runs it using your credentials. So don't write code to like wipe the hard drive because it runs as you. It'll only wipe your files if you do that. And it runs your program, and then it compares the output of your program against the output of my program. If they match, you get a point. Then it goes on to the next test case. Get a point, get a point, get a point. For this one, there's 5 points. You get 5 points on Canvas. That's it. So after you finish, don't like move your file. That's something some students do. Like, okay, well, I'm done with 99 bottles. I'm going to move it out of the directory or something. Don't do that. Leave it there until it's graded. Okay. Once it's graded, I would still leave it there just in case I have to regrade it or something like that. So, and that is it. Yeah, that shrimp burrito smells good. So I am going to sign off now. Thanks for coming out, everybody. I hope you guys enjoyed. Oh, Ginkan Onsen in Japan. Be amazing to be there right now. Some snow coming down. Hot springs. Be amazing. All right. Good night, guys. Peace.